माय डियर सेकेंड ईयर स्टूडेंट्स मु तुमर ये ऑनलाइन क्लास रे प्रथम आरंभ करछि इनवर्स ट्रिगोनोमेट्रिक फंक्शन। प्रथमे आम यही चैप्टर को जीवा पूर्वर प्रथमे आम जानिबा फंक्शन। तार डेफिनेशन ए रिलेशन F from set A to set B is said to be a function if it satisfies following. Number 1, domain of the relation F must be equal to set A. Number 2, F is not in one many relation. जो रिलेशन लो ये दुईटी गुण थिबो ताको आम फंक्शन कहवा। आम गोटे उदाहरण नवा मन कर इटा ए सेट इट एलिमेंट अच्छी 1 2 3 आम तांकर फंक्शन मानकर एरो डायग्राम गोटे करछे ए रिलेशन मानकर एटा हला बी। सपोज ये जो रिलेशन अच्छे ताको आम कहे F1 एठी बी सेट रे जो मैंने मेंबर अच्छंती ताको आम मन कर कहे ABC। एठी F1 रिलेशन ले domain of F1 or set containing 1 2 which is not equal to A. Second गुण F1 is not an one many relation. तो यही उदाहरण रे F1 रिलेशन टा A सेट रु B सेट को डिफाइंड होइछि। A सेट रे एलिमेंट अच्छंती 1 2 3 B सेट रे एलिमेंट अच्छंती ABC। F1 रिलेशन 1 को A सहित एसोसिएट करछि 2 को B सहित एसोसिएट करछि तेणु डोमेन ऑफ F1 हैला 1 2 जोटा कि A सेट सहित समान हो नाही। तले F1 रिलेशन टा ए फंक्शन हबार जो प्रथम कंडीशन ताको वायोलेट करछि द्वितीय कंडीशन टा सैटिस्फाई करछि तेणु F1 रिलेशन इज नॉट ए फंक्शन। सेकंड एनादर आम रिलेशन कहूँ ताको कहूँ F2। से समान सेट आम नहीं ABC समान एलिमेंट अछंती 1 ए को एसोसिएट होईची 1 बी को एसोसिएट होईची सी को होईची एइथरो हमारा डोमेन ऑफ F2 last set containing 1 2 3 which is equal to A. Second condition F2 1 लो दीटा इमेज अच्छी A गोटे B गोटे therefore F2 is not ना is A sorry is in one many relation. F2 पाखरे प्रथम गुणटा अच्छी द्वितीयटा ना तेणु ये गोटे फंक्शन हेनी जहाँ पाखे दीटा गुण भी नथिबो सी भी फंक्शन हेनी आम एवं तेणु ये दीटा कथा को विचार करिकी देखिबा आउ गोटे रिलेशन F3 से समान एलिमेंट आम नौचु आम जानूँ डोमेन ऑफ F3 इक्वल टू 1 2 3 which is equal to A. डोमेन ऑफ F3 टा A सेट सहित समान and F3 is not an one many relation. F3 पाखरे फंक्शन हबार रिलेशन F3 पाखरे फंक्शन हबार दीटा जाक गुण अच्छी तेणु F3 इज ए फंक्शन. आम ए देखा F3 फंक्शन टा किमिति डिफाइंड हला ना फॉर F3 फॉर द फंक्शन F3 we have domain of F3 equal to A. Second ray F3 of 1 equal to A, F3 of 2 equal to B, F3 of C equal to 3. Sorry, F3 of 3 equal to C. Third, the range of F3 equal to B. B is called the codomain. For any function, if its domain and any function defined from A to B, if its domain is A and range equal to codomain, then we say it is a bijective function. Therefore, we write F3 is a bijective function. That means 1 1 and on 2. आम बाइजेक्टिव फंक्शन विषय डिटेल्स फंक्शन ले पढ़ा एवं आम खाली तुमको इनवर्स ये धारणाटा दौचे जे F3 इज ए बाइजेक्टिव फंक्शन फ्रॉम A to B. एबे आमे जानिबा जो फंक्शन माने बाइजेक्टिव हेबे तांकेर इनवर्स रहबे. then F3 inverse from B to A exists. Condition for existence of the inverse of a function is it must be bijective for the given domain and range. Bijective means 1 1 and 1 2. The property 1 1 property by injective property is a domain dependent property. 1 2 property is a range dependent property. Here F3 inverse of A equal to 1, F3 inverse of B equal to 2, F3 inverse of C equal to 3. हमें यह जान ले ताले हमें एबुटू कनक्लूजन या नबा जे if f a to b given by f of x equal to y is any bijective function, then its inverse exists, and f inverse is a function from B to A given by f inverse of y equal to x. Diagrammatically, if f then f inverse exists. If f is a function from A to B and is bijective, then its inverse exists. Then existence of inverse of a function is that it must be bijective. We are interested to study the inverse of trigonometric function. First we remember the natural domain and natural range of all trigonometric function. Natural domain and range of trigonometric function. For sine function, its natural domain is R. Its range is -1 to 1 closed interval. For cosine function, its natural domain is also R and its range is also -1 to 1 closed interval. For tangent function, its domain is R difference set containing odd multiples of pi by 2. That is written as 2n plus 1 pi by 2. n belongs to z and its range is R. For cotangent function, its domain is, natural domain is r minus n pi. N belongs to z. Multiple of pi, the angle multiple of pi must be subtracted from the set of real numbers. Range is r. For secant function, domain is r minus odd multiple of pi by 2. N belongs to z, and its range is r minus -1 1 open interval or minus infinity to -1 semi closed interval union 1 to infinity semi closed interval. Similarly, for cosecant function, cosec, its domain, natural domain is r minus n pi. N belongs to z. Its range is r difference -1 to 1 open interval or minus infinity to -1 union 1 to infinity. These are the natural domain and range of the trigonometric function. On these domain, they are not bijective. Suppose, for example, for sine function, we take the angle pi by 3 and 2 pi by 3. For pi by 3 and 2 pi by 3, and its range -1 to 1 closed interval, and its domain r, here is pi by 3, another is 2 pi by 3, and they all bear the value √3 by 2. Hence we say sine is not bijective, it is a many one relation, therefore it is not a bijective function. To make it 1 we have to restrict its domain. Similarly, other function follows. All these trigonometric functions are not bijective, particularly they are not 1 for this domain, but they have the onto behavior. To make them 1 and onto, we restrict their domain. Therefore, we write the domain and range of bijective trigonometric function. Domain and range of bijective trigonometric function. We restrict their domain. For sine function, to make it bijective, we take its domain is -pi by 2 to pi by 2 closed interval, which is known as its principal domain. Similarly, for cos, we take its domain 0 to pi closed interval. For tan, -pi by 2 to pi by 2 open interval. Similarly for cot 0 to pi open interval. For sec 0 to pi closed interval, difference the angle pi by 2. The range is as it is. For cosec minus pi by 2 to pi by 2 closed interval, difference set containing 0. The range is as it is. For this domain, sine, cos, tan, cot, sec, cosec, all the 6 functions are bijective. For this domain and these range, they are bijective. Therefore, for this domain and these range, their inverse exist. And we write the domain and range of the inverse trigonometric function. Then this value is domain and range are reversed. I write domain and range of inverse trigonometric function. For sine inverse function, its domain is minus 1 to 1 closed interval. Its range is minus pi by 2 to pi by 2. Just reverse of the bijective sine function. For cos inverse, suppose this is 1. For cos inverse, domain is minus 1 to 1 closed interval. Its range is 0 to pi closed interval. For tan inverse x, its domain is R. Range is minus pi by 2 to pi by 2 open interval. For cot inverse function, its domain is R. Set of all real number, range is 0 to pi open interval. For sec inverse function, its domain is 0 to pi closed interval. R difference minus 1 to 1 or open interval or minus infinity to minus 1 union 1 to infinity. These are the two semi open or semi closed interval. 2 0 to pi minus set containing pi by 2. For cosec inverse, the domain is same as that of sec, or minus infinity to minus 1 union 1 to infinity. Minus pi by 2 to pi by 2 difference set containing 0. We have to remember all these domain and range of the inverse functions. Inverse functions are also known as arc functions. We write sine inverse x is equal to arc sin x. Similarly, we write cos inverse x equal to arc cos x. That means if we write sin inverse x, then its domain must be minus 1 less than equal to x less than equal to 1. This is the domain for sin inverse x. And sin inverse functions takes those values which are lie within the closed interval minus 1 to 1. Similarly, cos inverse function takes those values which must lie within the closed interval minus 1 to 1. Tan inverse x takes those values which lie within the set of real lines. That means tan inverse x takes any real number as its domain element. But similarly, cot inverse x takes any real number and gives an angle within the range 0 to pi. Similarly, sec inverse x takes any real number except those lying in between the interval minus 1 to 1. Cosec inverse x similarly takes all real numbers except those lying in the interval minus 1 to 1. We must have to remember this. Then we observe what we write in the case of f3. Our f3, as we defined previously, f3 of 1 equal to a implies f3 inverse of a equal to 1. Similarly, f3 of 2 equal to b implies f3 inverse of b equal to 2. Similarly, f3 of 3 equal to c implies f3 inverse of b equal to c equal to 3. Since f3 is a bijective function from a to b and a is the set containing numbers 1 to 3 and b is the set containing numbers abc, and f3 inverse exists from b to a, in that case we defined f3 like this and f inverse like this. To celebrate some beautiful properties of inverse, I remember all of you that function f3. Then first comes to the property 1. Property 1 of inverse function. From this observation, you find f3 composition f3 inverse. Since f3 inverse, its domain is b, we take for this function the elements of a as their domain element, which is equal to f3 of f3 inverse of a, which is equal to f3 inverse of a is 1, f3 of 1, f3 of 1 equal to a. Therefore, for any function f which is bijective, in general we write f composition f inverse of x equal to x belongs to domain of f inverse. Similarly, another observation you observe. Now with this observation we write some property of the inverse trigonometric function. Sine of sine inverse x equal to x if -1 less than equal to x less than equal to 1. Similarly, cos inverse x equal to x -1 less than equal to x less than equal to 1. Tan inverse x equal to x if x belongs to R. Cot inverse x equal to x if x belongs to R. Sec inverse x equal to x if x belongs to -infinity to -1 union 1 to infinity. Vi cosec inverse x equal to x if x belongs to -infinity to -1 union 1 to infinity. This is a property we observe. Then another property, F3 inverse of composition F. Since we take the domain element of the F3, that is 1, here equal to F3 inverse of f of 1, which is equal to F3 inverse of f of 1 equal to A, F3 inverse of A equal to 1, and 1 must be belongs to domain of F. From this property of the bijective function f, we conclude the property 2 of the inverse trigonometric function. Sin inverse sin theta equal to theta if minus pi by 2 less than equal to theta less than equal to pi by 2. Similarly, you may write cos inverse of cos theta equal to theta if 0 less than equal to theta less than equal to pi. Tan inverse of tan theta equal to theta if minus pi by 2 less than theta less than pi by 2. Cot inverse of cot theta equal to theta 0 less than theta less than pi. Sec inverse of sec theta equal to theta if theta belongs to 0 ରୁ pi closed interval and theta not equal to pi by 2. Cosec inverse of cosec theta equal to theta if theta belongs to minus pi by 2 to pi by 2 closed interval and theta not equal to 0. These are the principal value branch of the inverse trigonometric functions. We remember these two property. In the next class, basing on these property, we will first solve some problems and then proceed for further property. Thank you.